we already discussed, there is no any difference in terms of a construction of a table, a forward difference table and backward difference table, but only difference is what? Only difference is in terms of a notation. Means the first term of a first order difference represent means del y0, means in case of a forward, in case of a backward, this one represent this one denoted the what? Value of a del y1. So suppose here we try to solve, we try to find out the value of y for a given value of x. Suppose here this one is a given, this one is a tabular value, x, y is a given. Suppose this one is a 40, and now just we noted down the values of this one, 40, 50, 60, 70, 40, 50, 60, 70 and 80. These are the given values of x. Now, what are the values of y, 80 as well as suppose 90 is also given. 90 is also given. So, how many number of x is given? 1, 2, 3, 4, 5, 6. 6 values of ordinate is given, and what are the values of y? This one is a 184, 184, and next value is a 204, 204, and next one is a what? Next one is a 226. Here I have already noted down the values for this one, 226, 250, and next one is a what? 276 and 304, 276 and 304. Once we verify either we noted down the correct value or not. This one is a 184, 204, 226, 250, 276, 304. Now, if we try to find out the value of if this one is a tabular value. Now, what is our aim? Our aim is to find out the value of y at x equal 43. To find out the value of y at x equal 43. This one is the problem. So we try to find out the value of y for given value for x. What is x equal what? X equal 43. So we apply the forward interpolation formula. We try to find out the value of y, which is nearer to the initial value, nearer to the first value. Then we apply what? We apply the forward interpolation formula. If we try to interpolate the value of y, which is nearer to the last value, then we apply the what? Then we apply the backward interpolation formula. So, to apply any formula, either neutral forward or backward, then first we construct the what? Difference table, forward difference table. So, how many number of terms? 1, 2, 3, 4, 5, 6 terms. So, what is the maximum degree of a polynomial that we able to fit? Means, what is the maximum degree of a polynomial we able to find out? Means if there is a 5 term, there is a 5 term, there is a 6 term, 2 to 4 to 6 term, then we able to find out a polynomial of a degree 5. So first we find a what? We find a first order derivative, del y. What is the difference between 204 and 184? If we difference subtract this one is a what? This one is a 4 minus 4, this one is a 0, this one is a 10 minus 8, this one is a what? 20. This one is a what? This one is a 22. 22. This one is a what? 24. 24. This one is a what? Difference between these two is a what? 22. Difference between these two is a what? 24. Difference between these two is a what? 26. 26, and difference between these two is a what? 28. This one is the first order difference. If we write a second order difference, this one is a 2, this one is a 2, this one is a 2, and this one is a 2. What is the third order difference? Third order difference becomes 6. So, from the difference table, what we conclude? Directly with the help of a difference table, if second order difference becomes constant, means this data satisfy a polynomial of degree 2. polynomial of a degree 2, because third difference onward become what? Onward become 0. So with the help of a difference table, we also means able to predict what is the degree of a polynomial. So if second difference become constant, so this data, this tabular value satisfy a polynomial of a degree 2. If third difference is a constant, then this one satisfies the tabular value satisfies the polynomial of a degree 3. If a fourth difference is a constant, degree 4. Fifth difference is a constant, then this one is a degree 5. Apart from means we are unable to find out means a sixth order difference. Far from the means after fifth order we are unable to find out the value of a forward difference. So here now what is the value for x, where we try to find out the value for y. So here we write, there is no need to write all other terms, only write to a first three term of a forward interpolation formula. So what is the first three terms? Standard formula with the y0 plus u del y0 plus u minus 1 upon factorial 2 del 2y0. Now all other terms become 0. There is no need to write all other terms, become all other differences become 0. Means del 3y0 with a 0, del 4y0 with a 0, all other terms with a 0. So there is no need to write down all other terms. But in examination you may write first the formula up to nth term, then you put the values of here, means y del y0, del 2y0, and again here for sake of convenience, for sake of standard formula, here we write what? U minus 1, u minus 2 up to u minus n minus 1 upon factorial n del n y0. So just put the values of here. What is the value for u? Obviously u is a what? X minus x0 upon h. x0 is a what? First value. We denote that this one is the x0, this one is the x1, this one is the x2, this one is the x3, this one is the x4, this one is the x5, and corresponding values for y is the y0, this one is the y1, this one is the y2, this one is the y3, this one is the y4, and this one is the y5. Now what is the value for u? X is a what? X is a value of where we try to find out the value for y. So this one is also given. So x is a what? X is a 43. What is the x0? x0 is a 40. First value. Divided by h. H is a what? Class interval. Because forward interpolation formula or backward interpolation formula, this one is only applicable for equal class interval. So what is the value for h? The value for h is here 50 minus 40, 60 minus 50, 70 minus 60, 80 minus 70 means a 10. So this one is a what? 3 by 10. This one is a what? 0.3. 0.3. This one is a value of a what? This one is a value of a. So be able to find out the value of a u, and y0 is already given. Del y0 is this one, del 2y0 is this one, del 3y0 is this one. So y equal what? Y equal y0 means 184. 184 plus u is a what? 0.3. 0.3 into del y0. What is the value for del y0? Del y0 is a 20. Plus u is a 0.3. 0.3 into 0.3 minus 1 divided by factorial 2 means 2 del 2y0. What is the value for del 2y0? The value for del 2y0 is a what? The value for del 2y0 is a what? 2. So if we simplify this one, what is the result? Result already we noted down the result. 189.79. 189.79. So this one is the result. You may also verify this one. This one is a lie 43. This one lie between 184 to 204. So almost I think this one is the correct result. 189.79. This one lie between 184 to 204. So now here also there is a need to clear. If we try to find out the value between x0 to x1, then we consider here x0 is a 40, then here this one is a y0, this one is a del y0, this one is a del 2y0, this one is a del 3y0, del 4y0. In some book you also see this one, means if you try to find out the value, means here 61, if you try to find out the value of this one, then they consider that this one is a what? This one is a x0, this one is a what? y0, then correspondingly this one is a what? Del y0, and this one is a what? Del 2y0, del 3y0, and so on. But in some books, either you try to find out the value of between this class interval, or between this class interval, or between this class interval, or any values, always you consider x0. So obviously, if we try to find out the value between 60 to 70, we try to, you need to initialize this one is a what? This one is a first value. Means you consider this one is a x0, and this one is a x1, this one is a y0, this one is a del y0, this one is a del 2y0, del 3y0. So here you only means use the lesser number of order of forward differences. You try to find out the value of 61, and you use what? This one is a x0. So some book follow this one, means always they consider x0 is the first value, and some books in some books this one is means if value lie between 60 to 70, then they consider 60 as an initial value. If you try to find out the value of y between 50 to 60, then they consider 50 is the what? Initial value. So if we try to find out the value of 72, then this one is considered as a what? x0. This one is considered as a what? y0. This one is considered as a what? Del y0. This one is considered as del 2y0, and so on. So you are able to, means if there is a del 3y0, you are able to find out the value of del 3y0 if you consider this one. So there is no need of confusion. Either you may also consider this one is as x0, you may also consider, if you try to find out the value between 70 to 80, you may also consider this one is a x3. So this one is a thumb rule, means if a value is nearer to the first value, then we apply a forward interpolation formula. If a desired, means if unknown value is nearer to the, means if we try to calculate the value of a y for a given value of a x, and if x is nearer to the last value, then we apply the backward interpolation formula. If the, means desired value is nearer to the central value in between the given set of values, then we apply the central interpolation formula. So this one is a very simple numerical problem. Somehow if we try to find out the polynomial, we satisfy the given tabular value, means this tabular value, we satisfy this tabular value, then how we fit a polynomial, how we find a polynomial, desired polynomial, to satisfy the given tabular value with the help of a Newton forward interpolation formula. So how rather than to write a value of x, means now we try to find out a polynomial. This example now says to what? Here we are not going to find out the value of any value of x. We find a polynomial, general polynomial. Polynomial will satisfy this data. Polynomial satisfying the given tabular value, this tabular value, and so this tabular value. this tabular value satisfies the polynomial. They satisfy this set of addition. So what you need to do, you write a forward interpolation formula. Obviously the difference table remains unchanged. So difference table means a second order difference with a constant, third order difference onwards becomes 0. So what is the polynomial? We satisfy the given data. The degree of polynomial is a 2. That we predict with the help of what? With the help of this difference table. Now, how we find the polynomial? Here we write y equal, what is the value for u? Now u become what? U become x minus x0. x0 is what? 40. x0 is 40 upon h. h is what? 10. So this one is the value u. Now just put these values in a Newton forward interpolation formula. This become what? Y equal y0. y0 is a what? y0 is a first value. This one is a 184. 184 plus u. u is this one. X minus 40 divided by what? Divided by 10. Plus into del y0. What is the value for del y0? 20. This one is a 20. This one is a 20. Plus u means again u minus 1 x minus 40 divided by 10 into u minus 1 x minus 40 divided by 10 minus 1 upon factorial 2. Upon factorial 2 means the value for this one is a 2. What is the value for del 2y0? Del 2y0 is a 2 multiplied by 2. And there is no need to write all other terms. So what is the value for y? Y become what? 184 plus this one is a 2 time of what? 10, 20. This one is a cancel out. So 2 time of x minus 40 plus this one is a x minus 40 and this one becomes x minus 50 divided by 10 into 10, 100, 100 into 2, 200 and divide this one cancel out divided by 100. So if we simplify this one, y equal what? Already we noted down the value for this one. The value for this one is a 0.001 x square plus 1.1x plus 1.1x plus 124, not a 120 because this one is not a 120, 124. So what is this one is a correct result. So similarly, there are different variety of questions. So there are different variety of questions. Now we try to find out the solution of some more problem. We try to solve some numerical example based on a forward interpolation formula and backward interpolation formula. So in case of a forward interpolation formula, as we discussed earlier, means how we find a value which is nearer to the initial value and how we find the value of a y which is nearer to the last value. Means with the help of a forward interpolation formula, we find a value of a y nearer to the initial value with the help of a forward interpolation formula. And then again we discuss with one example how we find a polynomial which satisfy the given set of values. Now here one another type of example means here the data is given what? Weight of students and the weight of a student between 0 to 40 is there is a 250 student and 40 to 60 weight between 40 to 60 there is a 120 student and weight between 60 to 80 there is a 100 student, and weight between 80 to 100 there is a 70 student, and weight between 100 to 120 there is a 50 student. Now question is find the number of a student whose weight is between 60 to 70. So here directly we cannot apply the forward interpolation formula or backward interpolation formulas. So first we convert this class interval into a one variable. So how we write this one in a one variable? So here we write weight is less than. Here we consider what is the x. X is a less than weight. Weight here less than. This one is a what? This one is a x. Here we consider this one is a x. And corresponding number of a student is a what? Y. Suppose y is a what? Corresponding number of a student. Number of student. This one is a y. So here we try to find out fx. We satisfy this x. So here we write a number of a student whose weight is a what? Less than 40. Less than 40, then here we write what? Less than 60. Less than 80. Less than 100. Then less than 120. Then obviously less than weight 40 is how many number of a student? 250 student. So here we write 250. And less than 60, obviously between 40 to 60 there is a 120, and less than 40 then this one is a 250. So less than 60, in a less than 60 this number of a student also included in a less than 60. So total number of a student less than 60 is what? 370. Now next one is a less than 80. So less than 80 there is a 470 student, and less than 100, 470 plus 70, this one is a 470, 30, this one is a 540. So 540 and plus 50 student, this one is a 590. Once we check this calculation, 250, then 370, then 470 plus 70, this one is a 540 and 509. Now if we construct the difference table of this one, means del y. What is the value for del y? 370 minus 250, this one is obviously, this one is a what? 120. This one is a 100. This one is a 540 minus 470, this one is a what? 70. 470, this one is a 70, and this one is a what? This one is a nothing, it's 50. Means the difference of these two is a what? 120. Difference of these two is a 100. Difference of these two is a 70. Difference of these two is a 50. This one is a first order difference. Similarly, what is the second order difference? Del to y, this one is a 100 minus 20, this one is a minus 20, 70 minus 100, this one is a minus 30, and 50 minus 70, this one is a 20. So 50 minus 70, 70 minus 100, this one is a minus 30, and this one is a minus 20 again. This one is a what is a third order difference. Del 3y is a minus 3, minus 20, minus 3, minus 20 become what? Plus 20, this become minus 10, and minus 20, minus 30, minus plus become plus, minus 20 plus 30, this become plus 10, and del 4y, 10 minus 10, this one become what? 20. So this one is what? This one is our difference table. If we assume that this one is a variable x, weight is a less than x. Now question is find the number of a student whose weight is between 60 to 70. So we have a weight less than 60. So if we find a weight less than 70, then what will happen? Here there is a number of a student whose weight is less than 60, and if we find the number of a student whose weight is less than 70, then we subtract from number of a student whose weight is 70 minus number of a student whose weight is 60. Now, so what is the x0 here? Here we assume that x0 is what? x0 is 60. So first we write down what? We write the formula of what? Forward interpolation formula. So forward interpolation formula, how many number of terms here we write? We write up to a fifth term. So what is the formula? Formula is a y equal y0 plus u del y0 plus u minus 1 upon factorial 2 del 2y0 plus u minus 1 u minus 2 upon factorial 3 del 3y0 plus u minus 1 u minus 2 u minus 3 upon factorial 4 del 4y0. Now what is the value for u? Obviously, what is the value for x? Here we assume that what is the x? X is a what? X is a 7. So what is the value for u? U is a what? U equal x minus x0 upon h by 2. So because x0 is a what? x0 is a 40. So here x0 is a 40, so x0 is a 40, 70 minus 40 divided by 20, because h is a what? H is a 20. So what is the value for u? U become 70 minus 40, this become 30, 30 by 20, this become 3 by 2. Now just put the values of to find out the y70, what is the y0? This one is a y0. If we assume that this one is a what? This one is a x0, this one is a x1, this one is a x2, this one is a x3, this one is a x4. So corresponding values of a y, suppose this one is a y0, y1, y2, y3, and this one is a y4. So there is a 5 terms, so there is a need of a what? There is a need of a 4th order forward differences. So y70 is the what? y0. y0 is a 250 plus u is a what? 3 by 2 and del y0. Del y0 is a what? Del y0 is this one is a del y0. Del y0 is a this one is a 120 plus 3 by 2 into 3 by 2 minus 1 divided by 2. Del 2y0 is a what? Minus 20 plus 3 by 2 into 3 by 2 minus 1, 3 by 2 minus 2 divided by factorial 3. And what is the value of del 3y0? This one is a minus 10. And what is the last term? Last term become what? 3 by 2 into 3 by 2 minus 1 into 3 by 2 minus 2 into 3 by 2 minus 3 divided by what? Factorial 4 and factorial 4. And what is the value for del 4y0? This one is the value for del 4y0. This one is the del 3y0. This one is the what? Del 2y0. So here we write this one is into a 20. So if we simplify this one, 250 plus this one become 180. So like this one, if we try to simplify this result, then y equal, here we noted down the values of this one, This one is a 250. After simplification of this one is a 180. After simplification of this term, I have already calculated. This one is a minus 7.5. Minus 7.5. This one is a minus 7.5. And next one is a plus. This one is a 0.625. 0.625 plus, again we write down the values. This one is a 0.4687. 0.46875. After simplification, what is the value for this one? Value for this one is a 423. 423.59. This one is a number of students, so number of students cannot be in a fractional part. So what is the equivalent number of a student? This one is a, suppose we consider this one is a 424. So 424. So this one is a 424. So number of a student whose weight is less than 70 is a 424 students. So 424 students, but what is our aim? Our aim is to find out the student whose weight is between 60 to 70. Now whose weight is between 60 to 70? So this one is what? Less than 70. Less than 70. How many number of a student? 424. And this one is already given. What is the weight of number of a student whose weight is less than 60. So number of a student less than 60 is a what? 370. 370. So here the number of a student whose weight is less than 70 and number of a student whose weight is less than 60. So between 60 to 70, how many number of students? So 424 minus 370. So this one become what? This one become 54. So there is a 54 students. What is the answer of this one? There is 54 students whose weight is between 60 to 70. So this one is another type of question that we solve earlier. Means first we try to solve one simple example. Means what is the value of y for given value of x if x is nearer to the first value. Then we try to find out a polynomial which satisfy the given data. And next, if in terms of a class interval, if any data is given, then we first arrange this one in a one variable. We try to write this one is not in a class interval. We try to write this one is less or greater than. So if once we write these data, we arrange these data in a form of a less than or greater than. Then again, in a similar manner, we find first a forward difference table. Once we construct the forward difference table, then we write a forward interpolation formula. And once we write the forward interpolation formula, then find the value of u. U is the what? X minus x0 upon h. Once we find the value of u, then we put the value of u and del y0, del 2y0, del 3y0, del 4y0 from the forward difference table. So these are the some types of example based on a forward interpolation formula. Similarly, there is a different question you can solve based on a backward interpolation formula. But when we apply a backward interpolation formula, we apply a backward interpolation formula if we try to interpolate the value of a y which is nearer to the last value of ordinate. So last value of the ordinate means near to the 120. Means if we try to find out the number of a student whose weight is 110, then we get a more accurate result if we apply what? If we apply a backward interpolation formula rather than to apply a what? Rather than to apply a forward interpolation formula. So we apply a what? We apply a backward interpolation formula if we try to interpolate the value of a y which is nearer to the x. We emphasize more and more means with apply a backward interpolation formula if we try to interpolate the value of a y which is nearer to the last value. So this one is all about a what? All about a forward interpolation formula and backward interpolation formula.